Welcome to Flores Mathematics. Today I will discuss some Ncert problems based on mapping. Okay, so I have already completed the concepts of mapping, the kinds of function, onto function, into function, and many one. What is many one and what is one function, etc. Right. So let's start today's session. So our first problem is, let A be the set of all 50 students of class 12 in central school. Let f maps a to n be a function defined by f of x equals to roll number of student x. Now, so that f is 1 but not onto. Okay, so there you have to prove two consecutive function, that is f is 1 and not onto function, right? So how can we do the problem? So first you have to do here f associates each student of his or her roll number, right? Because of student x, so here f associated. Okay, so here f associates each student to his or her roll number, right? Roll number. Now, since no two different students of the class can have the same roll number, right? Because each student have their its own his or her own roll number, right? So since no two different students of the class can have the same roll number, right? Same roll number. And the from the definition of one function, we already knew that different elements of set A, okay, if different elements of set A have different images on B, then we can say the function is one function. So here satisfy the condition that since no two different students of the class can have the same roll number, so you may write here, therefore f is 1 therefore f is 1 right? Now how can we prove the function is not onto function? So let's see. We observe that here that f of a equals to range of f that is 1, 2, 3 up to 50. Okay, because a b in the question, see in the question there is written, that this a be the set of all 50 students of class 12, right? Now we observe that f of a equals to range of f equals to 1 to 50. That does not belongs to n. That is, because define the function, that is f maps a to n. See, let f maps a to n here, right? So that is range of f is not same as its codomain. And from the definition of onto function, we already know that if range equals to codomain, then we may say that the function is onto function. But here f is not same as is its codomain, right? So here we may conclude that f is not onto. F is not onto, right? So this completes our proof that f is 1 but not onto. Okay. Now next move to the next question. Now our next question is, that is, so that the function f maps n to n given by f of x equals to 2x is 1 1 but not onto. Okay, the similar type of question it is the previous one. So f of x is defined as 2x, f of x equals to 2x. Now for first of all you have to prove its injectivity, right? So injectivity. So what is the definition of injection function or 1 1 function? So there is the definition that if f of 1 equals to f of x2, sorry, f of x1 equals to f of x2 such that x equals to x2, then we may say that the function is 1 1 function. So let's see about this f of x equals to 2x, right? So here let x1 and x2 belongs to n such that f of x1 equals to f of x2. Then we put the value x1 in 2x1 because f of x equals to 2x, right? So f of x1 that is 2x1 equals to f of x2 that is 2x2, right? Now 2 cancel, so implies that x1 equals to x2. That means it is clear that f is 1 1 function, right? It is clear that f is 1 1 function. Now what about its surjectivity? Okay, what about is its surjectivity, right? So it is clearly f takes even value. See here f takes even value because f of x equals to 2x. So it is clear that f takes even value. Therefore no odd natural number in n has its pre-image in domain, right? What is the definition of surjection function? That is if range equals to codomain of the function, then we can say that f is onto function. Okay, of f is onto function. But here it is clearly that f takes only 2x. So if we multiply any number in 2 by 2, then it will be even value. So f takes even values. Therefore no odd number or odd natural number rather than, so no odd natural number in n, that is in codomain, right? So in n has its pre-image in domain, right? In domain. Now what is pre-image here? So say here it is A and it is B and it maps f maps A to B, and here this element is 2 and 3. So we may write it 3 is pre-image of 2 under f. Okay, so this is the basic concept of pre-image. Okay, so here natural number, odd natural number in n has its pre-image in domain, right? So f is not onto, because we already know that if the function is onto, then it is there is a condition that range equals to codomain. Okay, so this completes our proof that f is not onto but 1 1 function. Okay, now what about our next problem? So our next problem, that is prove that f maps R to R given by f of x equals to 2x is 1 1 and onto. So what is the difference between the problem number 3 and the previous problem, that is problem number 2? See here F maps R to R, but in the second problem there F maps N to N. Okay, so here is the major difference between second and third problem. So this is your homework. Okay, this is your homework. I have 1-1. The proof of 1-1 is clear, because the same answer will be there will be written, but in for subjectivity there is a small change, and so you will try it. Okay, and I hope you will able to do it. Okay, now move for the next problem. So our next problem is so that the function F maps R to R defined as f of x equals to x square is neither 1-1 nor onto. Okay, nor onto. So how can you approach this problem, this proof? So first of all, what is the graph of f of x equals to x square? Okay, so we already know that the x square f of x equals to x square is parabola, right? See, this is 1, this is 2, and here this is 0, this is 1, this is 2, this is 3. Okay, so f of x equals to x square. Now we observe that minus 1 and plus 1 belongs to real number, the set of real number, that is R, such that f of minus 1 equals to f of plus 1, right? Because minus 1 whole square of minus 1 is 1, and 1 square is also 1. So f of minus 1 equals to f of 1. Okay, now that is there are two distinct elements, there are two distinct elements, different elements, right? That is minus 1 and minus 2 in R, which have the same image, Okay, so f is not 1-1, because from the definition of 1-1 function we already know that if different elements have the different image, then we can call f is 1-1 function. But here see, if it is a, it is b, and it is f. Now f of x equals to x square. So there are two distinct elements, that is minus 1, that also image plus 1, and plus 1, that also the image plus 1. Okay, so this is not 1-1, that is it is many 1 function. Okay, now move for the next proof. So what about its surjectivity? Let's see. So here, since f of x assumes only non-negative values, so no negative real number in R, that is codomain. Okay, codomain has its pre-image in domain of F, okay, that is R, so consequently F is not onto, because f of x equals to x square, so no negative real number in R has its pre-image in domain of F, that is in R, so consequently F is not onto. Okay, so these facts are evident from the graph of f of x also. Okay, see, there all are about the positive part, right? Okay, so next move for the last problem, the fifth problem. Okay, so our fifth problem says that so that f that maps R to R, defined as f of x equals to x cube is a bijection, So first, what about bijection? What is bijection bijection mapping? So bijection is nothing but 1 1 into mapping. Okay, 1 1 into mapping. Sorry, not into, it's onto. One onto mapping. Okay, so if one function is 1 1 and onto mapping, that is both of them 1 1 mapping and onto mapping also, then we can call the function as bijection mapping or bijection function. Okay, so how can we prove it? First, you have to prove that f is 1 1 function, then you have to prove that f is an onto mapping, then we write that f of x is a bijection. Okay, now so for 1 1, that is injectivity, what about injectivity? So let x comma y belongs to R such that f of x equals to f of y. Then what about f of x, that is x cube, and what about f of y, that is y cube? Now x equals to y, so these facts are evident from the graph also. If you are interested, then you can draw the graph also. So f belongs to, or f maps R to R is 1 1. Okay, 1 1. Now what about surjectivity? Let's see. So surjectivity. Okay, so what about surjectivity? Let or assume y belongs to R, so it's codomain. Okay, codomain. Then f of x equals to y implies that x cube equals to y, that is x equals to y to the power 1 by 3 1/3. Now clearly y to the power 1 by 3 belongs to R, that is that is domain. Okay, here domain for all y belongs to R, that is codomain. Okay, that is codomain. Okay, so finally, thus for each y belongs to R, that is codomain. There exists x equals to y to the power 1 by 3 belongs to R, that is domain, such that f of x equals to x cube equals to y. So finally, if maps R to R is onto, okay, hence f maps R to R, which is defined as f of x equals to x cube, is a bijection. So this completes our proof. Okay, so that's all for today. In the next video or next day, I will discuss some Ncert problems also, that based on mapping. So that's all for today. Take care. And a special announcement for you, that is, I have already started the tuition batch of class 12 mathematics. So if you are interested, then you can contact me in 750-148-9846, that number. Okay, so please like, subscribe my channel. Okay, take care. Bye bye.